Okay, this is Geometry Chapter 6 review. This chapter deals with polygons. Chapter 6.1 starts off with just basic polygon, which means many sides. Two basic types of polygons are convex, concave. Convex polygons are polygon that a side of it will actually cave in, or you can extend a side that will pass through the center of the polygon containing interior points. A convex polygon will have no interior points. Those are your normal polygons, such as just a triangle, a square, any of the normal polygons you're used to. You have many other polygons too. You also can have pentagons, hexagons, heptagons, all the ones that are down on the bottom of page 322 down here. And then we have a special polygon that sometimes are maybe more than, say, 12 sides of what we call an n-gon. Also from this chapter, we talk about what's called a regular polygon. A regular polygon is a polygon that is both equilateral and equiangular, or meaning that it has four congruent sides, four congruent angles. Or let me rephrase it: all congruent angles, all congruent sides, because it can be more or less than four sides or four angles. Also, on a polygon, one of the major theorems out of this one is that the interior angles of a quadrilateral. Now, quadrilateral is a four-sided polygon. The sum of the measures of the interior angles of a quadrilateral is 360. So, anytime you're looking for angle measures when it comes to a quadrilateral, such as in this problem right here, where they tell us to solve for x, we would simply say x plus 2x plus 70 plus 80 would equal 360. And after we do some basic algebra, we would find that x would be 70. So this angle would be 70, this angle would be 140. That's section 6.1 of the chapter that deals with your basic polygons. All right, now moving into the next part of the chapter, away from just a polygon, we've moved to a quadrilateral and now to what's called a parallelogram. A parallelogram is a polygon, it is a quadrilateral with both pairs of opposite sides parallel. Both pairs of opposite sides parallel. So in the definition here, they demonstrate this by showing the arrowheads. These two sides are parallel, and then these two sides are parallel. So that makes that a parallelogram. Also, a parallelogram has some other properties to it. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And then the diagonals of a parallelogram bisect each other. Diagonals join two opposite angles. So the diagonals of a parallelogram bisect each other. Those are the main properties of a parallelogram. Beyond a parallelogram, now we move into some more special types of parallelograms. We have actual three that we're going to look at, which is a rhombus, a rectangle, and a square. Okay, a rhombus is a parallelogram with four congruent sides, so it has all the properties of a parallelogram, but now the four sides are congruent. A rectangle is also a parallelogram, but it has four right angles. So it doesn't have, its opposite sides are congruent, but it has four right angles. And then a square is kind of the combination between a parallelogram and, a rhombus and a rectangle, in that it's a parallelogram with four congruent sides and four right angles. That makes up the three special parallelograms. All right, also, if a parallelogram is a rhombus, then its diagonals are perpendicular, or that means that they are going to form four right angles, okay, as seen there. Also, if a parallelogram is a rhombus, then the diagonals will also bisect the angles, which means split them into two congruent angles. And then if a parallelogram is a rectangle, then not only do the diagonals bisect each other, now you have all four of the bisected, or all of the four segments are now congruent if it is a rectangle. Okay. The last two special figures or polygons are trapezoid and a kite. Now, a trapezoid is a special shape in that it has several things going on. It has base, sides, and then it has legs. Also, a trapezoid, if the legs are congruent, we can have what's called an isosceles trapezoid. The properties of a trapezoid would say that if it's an isosceles triangle, isosceles trapezoid, then each pair of the base angles are congruent. So angle D would be equal to angle C, angle A would be equal to angle B. Also, in a trapezoid, if it has a pair of congruent base angles, then that would make the opposite sides congruent, which would make it isosceles. And lastly, a trapezoid, if it's isosceles, then the diagonals are congruent. So only when a trapezoid has the special property of being isosceles does it make the diagonals congruent. A trapezoid also has a special property called a midsegment. A midsegment of a trapezoid is a segment that joins the two opposite midpoints. Now, if you were trying to say solve for a midsegment, you would simply add the base measures together, divide by 2, and that would give you the midsegment, as seen here, 1/2 of, and we add the two bases together, and that gives us the midsegment theorem of a trapezoid. Now, the last special polygon that we're going to look at is a kite. A kite is a quadrilateral that has two pairs of consecutive sides congruent, as seen in this figure here, where not the opposite sides are congruent like most polygons, parallelograms, but now the consecutive sides are congruent. All right. So if a quadrilateral is a kite, then the diagonals are perpendicular. So kind of like in a rhombus, they meet at a right angle. And then lastly, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So in this situation, either A would be equal to C or B would equal to D, one of the two. And that is what makes up that polygon, a quadrilateral of a kite. Now, some other, that's mainly the main thing of the chapter, except finding the area of the polygons. You can find the area of a rectangle like you always have, length times width, or in this situation they call it base times height. That's the same thing. Area of a parallelogram is base times height, and the area of a triangle is A equals 1/2 of the base times the height. Now the other special ones are the area of a trapezoid it's A equals 1/2 of the height times the bases added together, the sum of the bases. The area of a kite and the area of a rhombus have the same exact equation for area, which A equals 1/2 D1 D2, where D1 and D2 are diagonals. So you find the product of the diagonals, take half of it, and that will give you the area of the kite or the rhombus. So as far as chapter 6 goes, a lot of properties to learn about the polygons. Problems that go with it, as long as you know how to the actual polygons properties, then you'll be able to solve the problems. That's chapter 6.